pricing a bond. So let's look at this example in figure 6.1, in which the coupon rate is 3%, the face value is $1,000, and the bond is maturing in 10 years. So this is annual coupon, so compounding is annual. Okay, so we will price it as mentioned at the rate of 1%, 3%, 4%, and then we'll price it for 10 years and 30 years. Let's do that. So 10 years, and let's also do this coupon 3%, $1,000 for 30 years. Okay, so we will say YTM price, YTM price. So we'll start with 1%, and because this is Excel, there's no oops, sorry, 0.01, 2%, 3%, 4%, 5%. Let's stop at 6%. It's too much. Now, price is actually calculated as, there are two ways to do it. One is the cash flow approach, and the other is the present value approach. So for the sake of illustration, let's do the cash flow approach just once. So equals this plus 1. So this is time, and this is the cash flow. So in the case of a bond, since this is annual compounding, let's just 9 and then 10 years. So each year we get equals 3% of C2, no, B3 of $10. So B2 times B3. So we'll have to fix that. $B, $2 times $B, $3. Or $30. So 30, 30, 30, 30, 30, 30, 30, 30, and then plus $B, $3. We don't really need $B, $3, but good. Now, so this is the next step. Now, so we have to find out the present value of these cash flows at some YTM. Let's just use a YTM of 2%. And the way we do it is simple, find out the present value. So it equals I5 divided by parenthesis 1 plus $J, $2 to the power of the time. Control D, 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 and just add it up. So adding the sum of the present values gives us the price today, 1089.83. And the fun part is we can play around with this. Once we've built up this formula of these cash flows, we can easily play around with it. But wait, now let's just look at the PV equation. We can use a PV equation. PV rate, the number of periods is $B, $4. $B, actually we are trying B $4 is good because we can then paste this formula for 30 years. B $4. The payment is B $2 times B $3. That is a payment, constant payment. Now, since we want the price to be positive, that means we're receiving the price, we have to make the payments negative. We have to pay them coupons. And then we have to pay the future value, the face value. So minus B $3. And then the type is 0. So 1189.43. Well, we can see that in this formula here, 1189.43. Same answer. So the PV function can actually be effectively used to find out the price of a bond. Let's see that again. So 2%, 1089.83. And so on. It becomes 1,000 or par at when the coupon rate is equal to the YTM. And just do Control D, Control D. In fact, it's so beautiful that our formulae have been attached to the respective cells that, nope, not properly. So we just moved by 1. Okay. So Control C, Alt ESV, Alt EST. Enter, and let's see what we've got here now. So Shift Control 1, 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 Shift Control 1 gets us the price. So we cannot do it here because we have to expand the number of periods to 30. But we can see, let's just check any of the formula. Well, the way to confirm it is this. When the coupon equals YTM, price equals par. So we can see clearly that increasing the TTM has not affected our formula. So PV, again, let's just see, D7, yes, D7 is the rate, E4, E$4 is the term to maturity, and then the coupon, and then the par value, and then the type. So that's the other thing to notice. The last thing to notice is for the same change in interest rate, i.e. 1%, you can see the price difference. Price difference is 99, 89, 81, 73. Well, if you look at the price difference for the 30-year bond, it's much more volatile. The fluctuation is dynamic. It's much bigger than the fluctuation in the 10-year bond. These are some of the things that one must know when talking about a coupon paying bond. Thank you for listening.